Okay, let's look at another example with two processors. Now this time I want to show another variation of that same thing. Okay, this time we will assume there is a processor called M, and it has a command or instruction for multiply. This is multiply 0 0 1 0 1 1 0 0. That is the machine language version for this processor M to do a multiplication. Processor, and we have another processor called processor N having 1 0 0 1 0 0 1 1, and this is the instruction for add. And also we will assume this processor N manufacturer has not put a instruction to multiply. So processor N does not have multiply. Okay, it can't do multiplication. Processor M can do multiplication, processor N cannot do multiplication. So let's see this situation. And we want the high level language, that is the test language, let's say we have done, to do a multiplication, and that to be available on processor M and processor N. Processor M, let's say, is okay because it has multiply, no? But processor N does not have multiply. So let's see how that is implemented. Okay, let's see how this is possible. We have two different processors. One supports multiply, one does not support multiply, but it supports add. Okay, but we want to use a high level language and do a multiplication, and we want to use on both processors. Let's see how that is possible. So let's take the two processors. Processor M, which has the multiply facility, processor N, which does not have the multiply facility, and we have the high level language test. Okay, now we are going to say display 4 into 3, that is multiply. Okay, so let's see how this works with this. Again, can this be understood by this processor? No, because this is not machine language. Can this be understood by this processor? No, again, it's not machine language of this. Okay, and this is not machine language of this either. So for display 4 3 won't work. So you need a translator. You need a translator for this separately, a translator for this separately. Okay, because this has to be translated to so in the M, it has to be translated to the M's instruction. In the N, this high level language has to be translated to N's instruction, N and M. Okay, so the relevant ones only it has to do. So let's see how it works. So display 4 into 3, and we are trying to give it to both, and let's see how each of these handle. This one takes, it has addition, so it it has multiplication, so it uses that multiply command. So this is the multiply command. Okay, multiply, this is 4 into 4 and 3, 4 in binary and 3 in binary. Okay, multiply. So by multiplying, it's going to do the job. In addition to that, we have to have the display command also. So let's come to that in a minute. So now this is this processor. Okay, this processor can directly translate the multiply to multiply, no issue. So no problem. But this processor does not have multiply. So what does this do? The translator of this will take the 4 into 3 and add the 4 3 times using the addition. 3 times it will add, because this processor can add. Okay, remember, it can't multiply, it can add. So using the addition 3 times, he will come up with the same result. Add the, see, this is the add command, 4, add 4, add 4, and when you add 4 plus 4, 8, 8 plus 4, 12, same as 4 into 3, which is 12. So here, this processor translator will achieve the same result by the process of adding. Okay, then the display part also has to be added to the relevant ones, and this set will be written into the secondary storage file with the display instruction part, this one. Okay, and now this one is doing multiplication directly, this one is doing multiplication by adding 3 times, because this processor doesn't have multiply. So this is a secondary storage. So now when this instruction goes through this, it will multiply this and come up with 12. 3 into 4, 12, and the display part. Okay, and using the display part, it will be displayed on the screen as 12. Here doesn't support multiply, but the translated version says add it 3 times. So it will add it 3 times, come up with the, send it to this, add it 3 times, come up with the same result, display 12 and show. So this is how translators help make the processors independent of the machine language. Okay, so this high level language now work on processor M as well as processor N. That is because the translator is helping us to do that. The translator will convert the high level language to the relevant processor's instruction set. Okay, so this translator will convert to this processor's relevant instruction set. This translator will convert to this processor's relevant instruction set. So the end result may be different, but the outcome is the same. So when you do this in the processor M or processor N through the translator, they achieve the same result, and therefore this high level language is also processor independent. It doesn't depend on the processor. The translator does the job for us, and so we can happily write the instruction for both as the same, and it will work on both the processors in this manner. Okay, let us see how a high level language can be made. Okay, so now let's see somebody is creating a new processor. Okay, this manufacturer decides, okay, this language called test is a nice language, so let's try and implement in my processor also. So what will he do? I'm just trying to show that process. Okay, how a new processor, when it is introduced, how they include a high level language into that. Okay, so in this case, let's try and include the test language. Okay, we want to include the test language available in the processor. At the moment, processor is created by the manufacturer, no translator. So processor X is there, our high level language test is there, display 4+5. Will this work directly? No, because this high level language won't be understood by the processor. This processor, here we are given saying this understands add as this. Okay, totally different to A and B. It's this one's add command is this one. Okay, so when you say this only, it will add, this processor will add. So what will the manufacturer do? He will look at all the instructions in the test language, test high level language, and write the relevant translation. So let's look at the translation for this display only, okay, for the moment. So here processor X's manufacturer will write the translator software. Okay, translator is also software. Okay, it's a program, your instructions and data, and that translator software's job will be to take the instructions from high level language test and convert that to the equivalent in the machine language. Okay, to convert test high level language to processor's machine language. So he will create this translator. So once the translator is created, this language is available on this processor as well. So that is how whenever a new processor comes in, if a high level language has to be introduced into that processor, the manufacturer or whoever is very familiar with this must write the translator. So once the translator is written, the translator will translate to the instructions required by this, and high level language need not worry about the details. Okay, so now in processor X also, by writing this translator, we have made test high level language available on the processor X also. So now you can send a 4+5 into this. It will convert. See, this is the add, right? So add 4 and 5 plus the display part. Okay, command, and this whole set gets written into the secondary file with the display instruction. And then once this is there, you can just in the secondary storage, and you can give it to the processor. Processor will display 9 on the screen. So we have made a new processor to be able to work with test high level language. So this is how high level languages work. Okay, and once this file is created, as I told you earlier, you don't need this part because this is there now. So now if I want to run it again, I can execute again I can execute again. It will take from this and display 9. We don't need this section. We can just forget about that. You can just use this and keep on running. Okay. Okay, this is same as now if I were to give you an example, if you take Microsoft Excel, Microsoft would have written the language Excel in high level language, and they would have compiled or they would have translated using their translator and got the exe version. This is the version they are given us. They don't give this. This is the version here. So we can double click on this and execute, and the processor will do that, and we are seeing Excel and we are working with Excel. Microsoft Word, same thing. Anything, games even, all of those are similar. Okay, right. Then we will